So where c is a number. So doesn't it make sense if I look as x is approaching anything, it's just going to be that number?
Yeah, we got it.
Okay, cool. Okay, so 2, let's look at the limit as x approaches a for c times f of x is going to equal c times the limit as x approaches a for f of x. So what this is saying is I can just pull that constant number out. The way it's okay. The way you can remember that c is a number, you can just think constant, right? Because a constant is a number. So what this is saying, I can pull a constant out, and it will still be the same question. Okay, the next one I want to talk about, I have 3 more for you all, is the sum law. The sum law, which says, if I have the limit as x approaches a of f of x plus or minus g of x, then I can just think about this. I can just use the distributive property. It makes sense when you think about it like that because we can break it up into the limit as x approaches a for f of x plus or minus the limit as x approaches a for g of x. So all I'm saying in this one is that we can split up. We can split up those 2 functions. Okay? 4 is the product law. 4 is the product law. And the product law says, it's very similar to the sum law, that if I have 2 functions being multiplied, if I look at their limit, the limit as x approaches a for f of x times g of x, just like the sum law, I can pull it apart. So I would get the limit as x approaches a, okay, of f of x times the limit as x approaches a for g of x. Okay? And the last one is going to be the quotient law. Okay? And the quotient law states that if I have the limit as x approaches a for f of x divided by g of x, so I'm just dividing 2 functions, I can again distribute that limit out. So it's going to be the limit as x approaches a for f of x divided by the limit as x approaches a for g of x. I need to learn how to write straight. Let k be some number. Okay, it is 350, and I did promise you all 350. So here's what I'm going to do. I am going to record myself do problems. That way you can play it forward and backward. I do want to give you just a couple more things. Oh, do you?
Oh my God, I'm so sorry.
No, it's okay. Do you need me to go back?
Let me just take a screenshot real quick.
Yeah, sure.
I thought I actually did something, but it was you.
No.
I got scared.
You're totally fine.
Oh wait.
Oh, did you get it? Sorry.
The screenshot didn't go. Hold on one thing. Just one more time.
Yeah, it's totally fine.
You take it. Screenshot. Take it. Thank you.
Okay, no problem. The last thing I want to leave you all with is this. Let k be some number. Okay? Let k be some number, dot, dot, dot. So if I have k over 0, that's going to equal positive infinity if k is not equal to 0 and k is greater than 0, or negative infinity if k is less than 0. Because it's just the general rule. If I have a really big number and I'm dividing it by 0, think about it. I know I can't divide by 0, but if I put 0.1, so that's like saying, let me give you an example and why it makes sense. If I have 5, I can't do divided by 0, right? Because that's undefined. If I do something close to that, let's say 5 divided by 0.01, 5 divided by 0.01 gets me 500. So it should make sense why I'm going to infinity. The other thing I want to say is 0 over k is going to always be 0, right? We definitely know that. 0 over anything is 0 if k is not equal to 0. I should be careful, right? Because not technically anything. Because if I have it 0 over 0, we know that to be indeterminate. So 0 over 0 and infinity over infinity are indeterminate. Are indeterminate. And we can add here to that end, if I have k over in positive or negative infinity, I'm going to get 0. Dot, dot, dot. Let me show you an example. Let's say I flip that top problem. So now it's 0.0, or let's say it'd be 5 over 1,000. I'm going to get a really small number. It's going to be 0.0005, I believe. Oh, just 2 zeros. I know, these are just the notes. Okay, do you all feel like mathematicians?
No. You made me lose my confidence in math.
No. This is getting you to think abstractly, right? That I can write one thing in multiple ways. And all we're saying is going back to that elementary concept of, Carlo, I'm going to use that always. I'm so glad you said it. Of just finding my output, right? What is my y? So, and we're just having tools to figure out how to manipulate. Okay, so my job is today I'm going to record a video doing two things. I'm going to first do problems regarding this, and then the second thing I'm going to do is also give you information about what's called